Hello. Well, I'm going to talk about Taylor polynomials to approximate functions. So this is like problem 8 in set 14 in our differential equations course. I've reworded the problem a little bit. Okay. The first question is to approximate the square root of 27 without a calculator using the Taylor polynomials T1 and T2. And then after you've done that, compute the error of each approximation, then using a calculator for that. Okay, so we want to approximate square root of 27. So the first thing to see is, well, we don't have a calculator, so this is about square root of 25, which is 5, right? That's sort of the zeroth approximation. In fact, that would be T0, we could say here. This tells you that we're going to want to use a center of A equals 25. In fact, that's the first question in the web work problem is what value of A do you want for the center? And so if you want to make sure you get that right before you continue. So what we're going to do here is we're going to say f of x, the square root of x, is going to be f of 25 plus f prime of 25 times x minus 25 plus f prime of 25 over 2 times x minus 25 squared plus dot, dot, dot. That's the Taylor approximation with A equals 25. We had the number A in there everywhere. Okay. We need to compute these three. Oops, that's f double prime. We need to compute those three numbers, and we do that by making the table. We do n, 0, 1, and 2. And then we take the nth derivative of x. The zeroth derivative of the function itself, that's square root of x, which we'll call x to the 1/2 to make it easier to differentiate. F prime of x is a half x to the minus a half. And f double prime of x, by dragging and dropping, I get minus a quarter x to the minus 3/2. Remember, we got to compute all of those before we compute the nth derivative evaluated at 25. Okay, so here's right, we have square root of 25, which is 5. That's the first number, and then we have a half times 25 to the minus a half. It's kind of useful if I write that as a half times 5 squared to the minus a half, because then that's a half times 5 to the minus 1, or a half times a fifth, which is a 10th. Okay. And then we have minus a quarter times, we've learned that, we'll call 25 5 squared to the minus 3/2, right? So 2 times minus 3/2 is minus 3, so this is minus a quarter times 5 to the minus 3. And then that's minus a quarter times 1 over 5 cubed, which is minus 1 over 4 times 5 cubed is 125. I've got 5 quarters, I got $1.25. So this is 4 times 125 is 500, right? So this is minus 1 over 500. So we've got these three numbers, f at 25, f prime at 25, and f double prime at 25. So let's not forget that factor of 2. So that means I'll just rewrite this. this is going to be 5 plus a tenth times x minus 25 minus, with the minus sign, 1 over 1,000, dividing that by 2, times x minus 25 squared plus dot, dot, dot. Okay? You don't need this anymore. All right, so remember that if we just stop here, this is t1 of x. And if we stop here, that's t2 of x, and I could, if I wanted, find t3 of x, etc. Okay, so now we can approximate, right? So we can approximate 27. In fact, we can approximate anything near 25. Square root of x is approximately 5 plus a tenth times x minus 25. This is the t1 approximation. The t2 approximation is that square root of x is about 5 plus a tenth times x minus 25 minus 1 over 1,000 times x minus 25 squared. Okay? And in fact, you can call it the t0 approximation is that square root of x is about 5. Taylor polynomial of degree 0 is just the constant. Right? So these are all good near x equals 25. And the closer you get to x equals 25, the better, right? So let's do that. All right. So we're now in a position to answer question 1. In fact, we could answer millions of questions like question 1, approximate square root of 24, approximate square root of 25.1, etc. But we just have this one number, which is cool. So the t1 approximation is that square root of 27 is about equal to 5 plus a tenth times 27 minus 25. That's just 2, so that's 5 plus 2 tenths, or 5.2. Right? And the t2 approximation is that square root of 27 is about 5 plus 0.2. We've done that already. It's the same. And then I have minus 1 over 1,000 times 2 squared. Right? I can do 27 minus 25. That's 2 in my head. So that's 4/100. So this is 5.2 minus 4,000, excuse me. That's 0.004. This is 5.196. All right, so that's our two approximations. T1 is that square root of 27 is about 5.2. And T2 is that square root of 27 is about 5.196. All right, so we didn't need a calculator for any of that. And the numbers you'll have in your web work are random. They're different than this, but you can do a similar type of thing. You can do the whole thing up to this point without a calculator. Now let's think about a calculator. First, what is 27 with a calculator? I can't write exactly what it is. You know, I have to go get my calculator over here. You think about how you do the second part while I go get it. All right, and I'm back. So I've got the square root of 27 is 5.19615 dot, dot, dot. So what I mean by this is it is exactly this number if I round to that many significant figures. 1, 2, 3, 4, 5, 6. I round it to 7 figures. Okay. So you notice that 5.2 is pretty good. 5.196 is even better, right? So, but let's quantify how good these are by doing this thing. Let's compute the error of each approximation. So the error of the T1 approximation is going to be 5.2 minus square root of 27. And I can't figure out what that is without a calculator, but I got the calculator, and that's about 3.85 rounded to 3 significant figures times 10 to the minus 3. And then the error of T2 is going to be 5.196 minus square root of 27. That is equal to, I got this, minus 1.52 times 10 to the minus 4. All right, so this means that the first approximation you see was too big. That was bigger than that. The second approximation was too small. That's less than that, so I get a negative number. Okay. So WebWork actually asks you for, first it asks you what A should be, say 25, then asks you for that number, and then it asks you that number for that number, okay? And you notice that it has a lot of verbiage about how you can actually have WebWork tell you that this is the correct answer, but then tell you that this is the wrong answer. Okay, that's because this itself has to be accurate to to 4 significant figures in WebWork. Okay, so actually, I wouldn't want to do that with my calculator. Here's what I'm going to do for WebWork. I'll show you with the screen share. Okay, we'll look at the WebWork first. Here's the WebWork, what you want to do. You want to put in the A, then you put in the 5.2, 5.196, and then you actually put in exactly the equivalent to what I did up here. Put in your approximation minus sqrt of 27 or whatever it is, okay? So it actually computes these numbers, okay? But don't be typing in, don't use your own calculator at all. If you do, you can do that. I'll have to type in probably more significant figures to make WebWork right. But just do that, and then it will give you, here's what it says when you enter it. You see I've got, these numbers should be familiar, except this is not written in scientific notation yet. Okay, so the next thing is I want to talk a little bit about some graphs. I've got a graph of the this function, and then the Taylor polynomial graphs. Okay, so first we have y is square root of x graphed here. And there's this point 25 comma 5, that's the point, the special point where I can compute everything, and I want to do the local linearization about that point. There's a local linearization of the function at 25. Okay, and then here is the local quadratic approximation in purple at 25. And to see that that's really a parabola, I can zoom out a bit, right? So I've got the red function, the square root, and then I got the line, which is the graph of the linear approximation, y is t1 of x. I got a parabola y equals t2 of x, quadratic function. And then if I zoom in on that point, 25, 5, you see, closer I zoom in, the better the approximations are. And at this point, the linear approximation is sort of peaking up quite a bit above, but the true function in red and the purple quadratic approximation are pretty close. Now they're even closer, and here we have our, here's 27 around here. Zoom in one more time. You can see here's 27. The y coordinates here are the two approximations that we used. If I zoom in even more, I can't even see the difference between these three functions. The original function, the linear approximation, the quadratic approximation are all on top of each other. All right, and as I said, you can also use this to get a good approximation for something like, say, 25.1. For 25.1, here, the first approximation is square root of 25.1 is about 5.01, right? And then I can get the next one. I don't know if I can do that in my head, but you can use these approximations to get approximation of square root of any number near 25. And the closer the number is to 25, the better the approximations are. All right. Well, stay well, keep your priorities straight, and let's finish out this semester strong. Okay, bye.